face a few quiz problems here. And first couple really anticipate what you're going to need to be able to do for homework. And then these review things that are going to be important in a few weeks when you have your exam. Okay. We want to start incorporating some review problems just to refresh our memory with things that you might have forgotten or gotten rusty on. Okay, so we got x squared, x minus 6 equals 0. Now, there are two ways to solve this. This is what's called a quadratic equation with an x squared term, an x term, and a number, and it's equal to 0. Okay. Right now, we don't know how to use a quadratic formula, or maybe you do, but we haven't covered it yet. We will. But it turns out that just factors, and everybody was doing the right thing with factoring. Trial and error, but that's okay. And I think most everybody got x plus 3 times x minus 2 equals 0. To get the solution now, well, if x plus 3 equals 0, then you're going to have 0 times whatever this is, right? When you multiply by 0, everything's 0, okay? The result is always 0. So if x plus 3 is 0, or x minus 2 is 0, this product is 0. And we've talked about this before, so. Some dots here, you know how to solve this by subtracting 3 from both sides. You get x equals negative 3, or x equals 2. And that it's a good idea to check. Three squared plus 3 minus 6 equals 0. And it actually should be negative 3 squared plus, let me rewrite it. Negative 3 squared plus negative 3 minus 6, 0. If we square negative 3, we get 9. Add a negative 3, it's the same as minus 3. Minus 6 equals 0. That gives us 9 minus 9 equals 0. And 0 equals 0. That checks out. Then if x is equal to 2, we get 2 squared plus 2 minus 6 equals 0. That's 4 plus 2 minus 6 equals 0. 6 minus 6 equals 0. 0 equals 0. And that fits. Okay. Second equation, I'll do a little more quickly. It's much the same as the first. It just factors a little differently. You've got x squared plus 7x plus 6 equals 0. So that you get x plus 6 times x plus 1 equals 0. And I think most people factored that correctly. Which then gives you x plus 6 equals 0, or x plus 1 equals 0. So you get x equals negative 6, or x equals negative 1. Now, I'm not going to write out the check, but if x is negative 6, you got 36 here. Then you got 7 times -6 is -42. And then plus 6. Well, 36 and 6 is 42, and you got -42. So you can do that. If you can do that in your head, it's okay. It's a good idea to write it out. All right. Now, let me warn you, people get in the habit of doing this. And then if I give you something like x squared plus 7x plus 6 equals 5, they want to write, okay, x plus 6 times x plus 1 equals 5. So x plus 6 equals 5, or x plus 1 equals 5. That doesn't work. Because the reason this does work is because multiplying by 0 gives you 0. Okay? So you can't do that unless you have a 0 over here. Make sense? Make sure you're aware of that, because I see that mistake fairly often. Okay. Now we got DBE equals A minus C. People did pretty well with this. Okay, you're trying to solve for D. So your D is here. So what you do is you divide both sides by BE. And the BE divides the BE, leaving it with the D. So the D comes out to the board there. Okay, makes sense? Okay. Now I'm pretty sure I'm recording. Let's see if I can put that on. Okay. So that was pretty easy. Now the second one has a little bit of a twist. And most of you have a pretty good idea what to do, but bottom, if you got a denominator in an equation, multiply both sides by that denominator. It spreads the equation out, and then they don't have any more denominators to mess with. Okay. So we multiply through by D. Well, the D, it divides the D, leaving it with BC. And this is then I'll reverse the order of multiplication for no good reason, but still looks better that way. That would be better if the D was on this side, but you can do it the way it is. And the key is, now we can easily solve for D. We just divide both sides by A plus B. So we're going to have BC over A plus B equals A plus B times D over A plus B. And this side is going to give us D, and this side is what it is. Now I'm going to just reverse the sides. And write the D I get over here on the left and write this expression over here. Okay? Make sense? So remember that, and try to remember. If you got denominators in an equation, you get rid of them. By both sides by each denominator. Okay? Now, and I was happy to see everybody added back correctly. Because one of the things I'm going to talk about, and I guess we're going to move into it immediately. 2/3 plus 3/5 equals, your common denominator is 15. So it's going to be 2 times 5 over 3 times 5 plus 3 times 3 over 5 times 3. And that equals 10 over 15 plus 9 over 15, which is 19 over 15. 19 is a prime number, so it's not divisible by anything except 1 in itself. So you're not going to reduce this. But in general, you want to see if you can reduce the fraction. Okay? All that makes sense? Okay. And the one thing that people need to especially focus on is what you do if you got a denominator in an equation. So for the 5th time, I'll mention that. I very seldom see people handle that correctly on an exam. Symbols or numbers. Well, we just added 2 fractions. So now I want to add A over B plus C over D. So I'm going to give you a second to work on that and see what you can do with it. And I think we just went out of focus because I reversed the board. Board and focus. Okay, now people are doing things that most people aren't doing anything. They're still staring at it. Okay, because it's unfamiliar. All of a sudden, I lay these 2 fractions with symbols. Okay, and you probably haven't seen it before, or if you have, it's been a long time. Okay, now the one thing you don't do is you don't do A plus C over B plus D. You can think how that would work out with 2/3 plus 3/5, right? You do the 2 plus 3, you get 5. Okay. And the 3 plus 5, you get 5/8. You don't get 19/15. Okay. So it just doesn't work at all. But what did you do with 2/3 and 3/5? You got a common denominator. What did you do to get that common denominator? So what would you do to get the common denominator here? Just give me a minute or so to think about it. Okay, that worked out pretty well for most of you. First of all, your common denominator. Common denominator is B times D. Okay. Now, always you get a common denominator if you multiply the denominators. Okay. You really want the least common denominator. In this case, that is the least common denominator. If you don't have a B in there, it's not a multiple of B, right? You got to have a D in there, or it's not a multiple of D. So it's got to have both a B and a D, but it doesn't need any more than that. B is a factor, D is a factor. Okay, so how do we get this? So we're going to want B, D in the denominator of both of them. Now, this one has an A in the numerator, but A over BD is not the same as A over B. So we can't just, essentially, we've multiplied the denominator here by D. Well, we also have to multiply the numerator by D. Okay? Because now, if we were to simplify this, the D's would divide out, we'd end up with A over B, wouldn't we? So this fraction is exactly the same as A over B. Over here. If we multiply the numerator by B, that matches the fact that we've multiplied our denominator, which is D, by B. So if we divide out the B's, we end up with C over D. So this fraction is the same as this one. That's equal then to AD plus CD, CB. Well, let's write that. Straight line in good letters, AD plus, and I'll write BC instead of CB because usually we write the letters in order. Sometimes we make exceptions to that, but not strictly wrong if I keep this as CB. It's just easier to organize what you see if we have everything sort of alphabetical order. So anyhow, we get that. Okay. Does that make sense? Yeah, that's exactly the same thing we did with 2/3 plus 3/5. Okay. That imitates every step. Let's do another one. Let's say we got X over YZ plus W over Y squared. Start by figuring out what your common denominator is, and then change the form of your fractions to where they're both expressed in terms of that common denominator. Least common denominator is a little simpler. Now, least common denominator has to include both of the denominators, right? And this includes both of the denominators. It's certainly got a Y in it, right? And it's certainly got a Z in it. And while we're at it, it's certainly got a Y squared. Y squared Z does the job too. Does Y squared Z contain a Y? Yeah. Does it contain a Z? Well, yeah, obviously. Does it contain a Y squared? Yeah. That's all you need. So you don't need Y cubed Z. You can use it, but this is going to end up a little more complicated. When you use this one, the expression you get is going to be a little more complicated than the expression you get here. And it'll probably simplify, and you might not notice that it simplifies. So, for many reasons, whenever possible, we want to use the least common denominator. When you get into stuff that we're going to be getting into late next week, you're going to be really glad if you have the least common denominator, because things get really, really messy if you don't. So you want to focus it. Okay, still, at this stage, if you use that common denominator, did it correctly, that's good. Okay, but let's make sure we start thinking in terms of least common denominator. And of course, open math is going to tell you the same thing. All right, so X over YZ plus W over Y squared equals what? Well, you got X over YZ, you got W over Y squared. Well, the only tell people to look at it is, what else do I need in the denominator here to get my least common denominator? Well, I need another y. So I'm going to multiply this by y over y. So that I'll have a y squared. And over here, clearly, I can multiply by z over z. And I get xy over y squared z plus wz over y squared z. Now, what would happen if I tried to use y cubed z? I mean, I can use it. It'll work, but let me just express what would happen. We multiply that by, well, this one by y squared over y squared. And we multiply this one by z over z. Sorry, I have to multiply this by yz over yz because we got to get a y cubed, right? And when we do, we get x y squared plus wyz over y cubed z. But look at the numerator. You can factor y out of the numerator. Okay? Write that as y times x y plus wz over y cubed z. Now, how does that simplify? Well, the y will divide into the y cubed. Since we can factor out the y, we have a y over y cubed, and that's then xy plus wz y squared z. Oh, and I never wrote it out what we had here. That's xy plus wz. When I have these two together. And clearly, this is the same as this. But I got this in two steps, and I had to take an extra step here to divide the y. Okay. So it got a little more complicated because I used a denominator which is not the least common denominator. Okay. And these things are gonna ultimately get pretty complicated. And you want to reduce that complication as much as you can. Okay? Avoid as much complication as possible. All right. Well, still, you know, I mean, everybody's doing pretty well here. So make sure you store this away. Now, you're not going to actually have to use this right away. One of the hardest things in this course is adding rational fractions. And we're building up to that. Okay. I wanted to review adding fractions with you now so that when we work through most of the next chapter and you get to adding rational expressions, you got to be ready to do it. Okay. You're not going to be stumbling as much over this. Well, let me go on a little bit. So let's say we have this expression, x squared plus 5x plus 6 over x squared plus x minus 6. Can you factor the numerator and the denominator? I think it can, because at least one of those is identical to something you factored in the quiz. Okay, now what I'm saying is that You can pretty much do the factoring. Hopefully you practice it a little more so you do it a little faster. You're going to have to do a lot of it in the upcoming chapter. So whether you practice it before or during time you work on the chapter, you're going to get pretty good at factoring, okay? You should get plenty of practice. Okay, so anyhow, everybody, either got this or was on the verge of getting it. You might have written these in a different order, but there we have it. Okay. Now, what do you notice about this? Open for discussion here in a second. Okay. So this is the same as x plus 2 over x minus 2 multiplied by x plus 3 over x plus 3. Does anything simplify? Well, what's x plus 3 divided by x plus 3? You can show me with your fingers. It's 1, because anytime you divide something by itself, well, what's division mean? It means how many of these does it take to make this, right? How many x plus 3s does it take to make an x plus 3? That's your division. Just like if you divide 6 by 2, you're asking the question, how many 2s does it take to make 6? Well, it takes 3. How many 6s does it take to make 6? 1. How many x plus 3s does it take to make an x plus 3? 1. Okay? Now, whether you remember it that way or just remember it's a hard and fast rule, 2 hard and fast rules. When you divide a quantity by itself, you get 1 for the reason I just told you. Okay? Because of what division means. And any number to the 0 power has to be 1. Okay? There's 2 things that people seem to frequently lose track of. Okay, so anyhow, this is 1. So that's x plus 2 over x minus 2 multiplied by 1, which is just x plus 2 over x minus 2. Okay? Now, the thing I don't like about cancellation is people then try to cross these x's out. You can't do that. You change the value of the fraction. If you cross the x's out, just cross them out, you get 2 over negative 2, which is negative 1. And that says that x plus 2 over x minus 2 is always equal to negative 1. Well, it isn't equal to negative 1 if x equals 10. It isn't equal to negative 1 if x equals 3. It's only equal to negative 1 if x happens to equal 0. So you can't cancel those x's. X plus 3 is a factor of the denominator. We just factored this to find that, right? X plus 3 is a factor of the numerator. So we can legally cancel a factor of the denominator with a factor of the numerator. So it wouldn't be mathematically incorrect to draw lines through this. It's just that people get carried away with lines and draw lines through all the x's. Maybe draw lines through the 2s and the 3s and everything disappears. Except a minus sign, so that's the whole thing is just equal to a minus. Well, I mean, if you don't understand the rules for cancellation, if you aren't careful about the rules for cancellation, you're likely to screw up badly. And I'm not sympathetic when I grade incorrect cancellations. Okay. Take more points off for that than just about anything else. Okay, so make sure you understand. First off, you're going to use cancellation. Make sure you're canceling factors in the same expression. Okay. And if you're using it, make sure that you could do it like I just did. I never had to cancel anything. I just separated out the like terms. Noticed that they divided to give me one and got my result. I didn't have to cancel the thing. Cancellation can be handy, it can be convenient, but be very careful that you're doing it right. Okay, there's almost nobody comes out of K through 12 doing cancellation correct. At least not in the experience of students I see. And it was bad before COVID, not COVID. Okay. Let's see. Let's try another one. Let's see if you can factor both expressions in the numerator, both expressions in the denominator. Okay. X squared plus 2x plus 1 is the perfect square. This is x plus y squared is x squared plus 2xy plus y squared. It's x plus 1 squared. So I'm going to write it that way. You can factor this as a special product. Now, so you factored it as x plus 1 times x plus 1, which is certainly correct, but learn to look for special products. And here we have x plus 5 times x minus 1. In the denominator, now if you factor it as x minus 1 times x minus 1, it'll work. That means x minus 1 quantity squared. And then you multiply that by x plus 1 times x plus 6. That's what this one is. So that's the factoring. And we see that we've got an x plus 1 here that matches up with one of these x plus 1s. Now, if you're into canceling, you can't cross this out and cross this out because this has two x plus 1s in it. Okay? Now, there's something you can do. You cross this out and cross out the 2 and make it into a 1. You understand what that means. So you can if you wish. But at this point, I'm going to go ahead and write it out as x plus 1 times x plus 1 times x plus 5 times x minus 1. Let's expand the whole thing out. And I notice I've got an x plus 1 that I can match up with one of these x plus 1s, and an x minus 1 that'll match up with this x minus 1, right? Well, I'm going to write it this way now. I'm going to write it as x plus 1 over x plus 1 times x minus 1 over x minus 1. Okay, or make myself a little note. I've used this x plus 1 and this x plus 1 and this x minus 1 and one of these x minus 1s. And that's still going to leave me an x plus 1 times x plus 5. And over here, an x minus 1. Six. I've still got the same numerator because when I multiply all these numerators, I'm going to have two x plus 1s match these. I'm going to have an x plus 5, and we're going to have an x minus 1. So everything in the numerator is matched. In the denominator, everything is matched. I've got two x minus 1s here and here. I've got an x plus 1 here. I've got my x plus 6 here. So everything matches up. Now, this is 1 and this is 1. So that's 1 times 1 times x plus 1. Write it this way, times x plus 5 over x minus 1 times x plus 6. Of course, that's just x plus 1 times x plus 5 over x minus 1 times x plus 6. And there's my final result. Okay? Now, you're not going to see me crossing things out. I don't want to encourage unnecessary habits. But if you look at this, you can see that I'm going to be able to pull out an x minus 1 here and an x minus 1 here. Okay? Now, if you see that I can factor these both out, then if you want to cross them out, okay. Okay, don't cross it out just because it looks like you could cross it out. Cross it out because you could factor this out and you can factor this out. Okay, and don't be crossing out both of the x minus 1s because, yeah, you can factor out both of them, but you're not going to have two of them up here to match the two you have down here. Okay, so you can see that you can do this. I recommend you keep writing it out until you know you can see it. Then you can start skipping it and crossing things out. Okay? So do as you wish. Just be careful because, again, if you cancel incorrectly, it screws everything up. And generally, if you just have one incorrect cancellation in a problem, you're not getting more than half credit in that problem, probably a little less. Okay? Even though you did everything else right. I'd probably give you credit if everything else was right or half of it. Instead of taking a couple of points off for a silly little mistake, I'm taking half your credit for a great big mistake, right? And that's appropriate to the situation because that's a biggie. If you miss a sign, everybody misses a sign now. You know, plus which should be a minus or double minus, you don't make it plus. I don't penalize that too heavily usually. Cancellation I do. Okay. So beware. And open math is going to show you cancellation right, left, and upside down because they thought that they were addressing people who knew better. Okay, but people don't know better. And if you do know better, great. Just do it right.